Hello, my name is Shane Newville, and I'm with the .NET MAUI team, and I am here to give a deep dive on creating unit tests for MAUI. I'm going to go over sort of the project structure and where you will typically look to try to create the tests. I'm not going to go through and necessarily diagnose and fix an issue. If you want sort of more of a foundation on that, I would recommend Javier's guide here, where he talks much more specifically about the complete guide. I'm assuming you've already figured out what the problem is, and now you just kind of want to write a unit test for it, and you think, where do I put it? So for this, I am going to take this basic issue, which Javier actually already created a PR for. That's why it was a good topic for this talk. So the basic idea here is that the user wants to be able to unfocus the search control. As you can see here, when I'm clicking this button, I have some code in the code behind that's calling unfocus, and you can see it is not getting focused. So we are going to fix that and then write a test for it. All right, so to start this conversation off, let's review the structure of the tests. So the basic structure, the basic types of tests, there are two of. We have device tests and we have unit tests. The unit tests are a basic Net 7 project that just runs XUnit, and that's it. So this is purely for logic-based tests, so things that aren't going to run on the platforms at all. It's only running within the context of a Net 7 library. So you can see these show up in the test runner. You can right click, you can run them. Easy peasy. You most likely won't be writing tests inside this core unit tests. But if you happen to be modifying something that's just very, that's not on the platform in core, you will, and you'll kind of know where to put them. But my guess is for the most part, people won't be putting tests there. The other area, which will be, this is the main area where you will be putting tests, are in device tests. So the device tests actually run on the device. Now the thing to note about the device tests, which can be a little bit confusing, is that this is using XUnit, but the problem, so the tests do show up in this runner, but currently this Test Explorer is not hooked up through the capabilities of being able to launch and run these tests via the Explorer. So you have to run them via test runner. And the test runner is pretty basic. You just set the core device test as a startup project, pick the platform you want to run the test for, and then run it. This can run on all available MAUI platforms. And it's actually a MAUI app. So it's a MAUI app running the tests. This runner was actually initially created by Claire, who wrote it for XUnit and Xamarin Forms, and then Matt basically took that project and pulled the whole thing over into MAUI. So at some point, it would be nice to pull all of this out into something other users can use, but for now, it just kind of it lives inside of our repository down here inside the test utils. So you have the core device tests and the unit tests. Device tests run on the platform. Unit tests just run in a library. The next thing to keep in mind is that there are different areas. So the two different areas, not the two, but the different areas are just sort of the different sort of conceptual spaces of MAUI. So the first layer here we have is core. So core is all of this is where all this is like where 95% of the platform logic lives. So code that's actually running on the platform. At this point, you'll probably know this because you'll have already fixed your issue and known that where your fix was applied. But just sort of breaking this down, you have the core space here. You have essentials. Essentials here is any issue that you're fixing that will be inside essentials. So inside the essentials code base here. So you'll see essentials also has device tests and unit tests. And device test is also using the same runner. All the device tests use the same runner that's down here in this space. That's based on the code here that Claire originally wrote that Matt ported. And so yeah, the core device test, this is where the majority of the testing happens. So you'll see there's a space here for every single type of control inside MAUI. All right, the other place that you might end up writing tests is inside the controls level. So the main place you might write tests inside the controls layer would be inside the control core unit tests. So this is, again, just a set of unit tests that you can run with the runner over here. Dun, dun, dun. Now, this is where all the XAML tests are based. So the stuff that's testing sort of aspects of the XAML code. So the controls layer of logic. So a lot of the behavior here that doesn't depend on the platform is here. So for example, if you were to look down at the shell modal tests, there's a bunch of tests here around firing, appearing, and disappearing, basic modal behaviors, stuff that doesn't really require any platform elements to test. These tests run super fast. So if you don't need to write a platform test, then just put it inside the unit tests. So, or we're kind of trying to keep the test at the lowest layer of requirements as far as like the least, put it at the place where it makes the most sense, that it takes the least amount of effort to run. The device tests obviously run on all the different devices, so those are a lot heavier. The unit tests just run on the libraries, and so those are really fast. So if you only have changes that are inside code that's not going to be platform specific, put those in the unit tests. So in controls core unit tests is where if you'll have any of that logic. And then we also have a set of device tests and controls. The whole point of this is just that there are certain libraries, or there are certain behaviors that are only implemented at the controls level. So for example, shell is only implemented at the controls level, collection view is, list view, our modal pages, certain things like that. And then there's certain implementations of things that there's only implementation at the controls layer. So for example, text transform, etc., are at the controls layer. But again, a lot of these things, you'll be kind of obvious what space this needs to go into, because it's basically just wherever your code changes were applied. So if your code changes were applied in controls.core, they're going to go in controls.device tests. If your changes only went to core here, I think I said control up here, but yeah, if they only go into your controls code, into the controls code up here, yeah, then they go into these device tests. Whereas down here, if they go into here, they'll go into these device tests. So that's kind of the basic location of all of the tests. All right, so let's kind of take this search bar handler one. I took what Javier basically already had set up. I have the fix. So I have the fix mostly applied. The idea here is that I've undone part of the fix. Here, I commented out these two events. So, because we want to prove that the test fails before we actually make it pass. So to kind of break down the way the tests work, kind of going back to my previous thing I said, we're always trying to build the test up. So trying to do as least amount of work that we have to, and then sort of building up how much is required to get a test to run. Ideally, the most basic type of test is just something of this nature, where you just new up the control. We have various helpers here, and then they're effectively just validating something. So this is just validating that when this platform control is created, that at the platform level, the search bar has this color. Very basic test. It's just news it up, and it's done. It's good to go. So that's kind of your most basic layer of tests. So the next level that you go to is when you have to attach an element to the visual layer. So for example, in this scenario, what we're testing is if a control is getting or losing focus, right? That's not really something you can do if the control isn't attached to the visual hierarchy, because you can't focus a control that's just existing out in the ether that isn't part of the window. So we need to attach the test to the actual window. So in order to do that, we have this helper, attach and run, right here, attach and run. So attach and run basically will attach your platform view to the runner. And you'll even see it. Like if you run the runner, you'll see your view get laid on top of the test runner. So this will actually attach it to the visual tree. There's some logic there that does some basic layout. So it'll lay out your element, I think, to a default of like 50 by 50. And then from there, you can kind of run what your test code is. So the test code here is fairly basic. I am attach and run. I'm invoking the handler, so I can invoke a focus operation. We have various helpers that you can use to indicate to wait for a certain state. We try to avoid having to do things, say, like this for arbitrary delays. Sometimes we can't get around it because of other issues that need to be fixed, but we have a good amount of sort of waits operations. So if you look, a lot of these exist sort of in assertion extensions. We have assertion extensions is where we're putting a lot of these. So you have there's some in here like keyboard, wait for the keyboard. There's some wait for layout. So if you want to wait for a layout to occur, you can do that. Yeah, there's a good amount of state information, async extensions you can use to wait for a certain thing to happen. So yeah, so this is our basic test. Let me see, did I keep this in the state of running? I think I did for where it was failing. So to kind of give the structure on the test runner, we'll just kind of wait for this to load up. So the test runner, like I said, you just set this as the test project. You run the project here, you deploy it, it deploys to the runner. You can go into here and then you search for your test, search bar focus here is working. I think I launched this since it was broken. All right, there we go. Perfect. See, fails. Test fails. So we've now proven that we have a test that fails. So now we want to fix the test. So now that we have our test fixed, we have it written, I can basically go here. I can add the changes in. All right, and one quick pro tip for all of you that are going to be watching this. If you're in the state where you're having to run your test a lot, one trick you can do is go into this test assembly view model here, and on the search query, you can put the name of your test here, which is helpful. Test assembly view model, plop it on the search query, which is helpful for occupying, pre-filling that text in. So it's going to take a little bit to launch this, but yeah, we can launch this and then we can see that the test has now passed with our written code. So those are most of the features at Core. Kind of some of the way Core is built is that we built it around these stubs. The main reason we're using stubs is these concrete stub classes, these ones that exist, is because you can't use in substitute on iOS. iOS doesn't let the proxy stuff, it can't create those types of things. So at some point, if iOS could do that, we will get rid of all of these stubs and do it all through in substitute. But for now, we do it on the stubs, which since it's a lot of shared concept there, those kind of can cause some annoyances, but that's how these work. We try to make them as thin as possible so that they don't overrun each other. But yeah, that's basically how the core tests work. So the thing to keep in mind is that these core device tests, this is at a layer below controls. So that's why we have the stubs, because this doesn't have access to any of the XAML elements. It does everything kind of through like the interfaces that work against the various handlers. So All right, look at that. It looks like it's a deploy. I was able to talk my way until the deploy. Maybe. Hold up. Wait for it. All right, there we go. So now it's working, reading the assemblies. We click on here. Now because I filled it in, we just have our test, and we click on it and boom, look at that, success. Haha, the test that we did works, great. And you can, I don't know, you can maybe see it real quick. You can see the search bar pops up there really quick in that corner. Doop, pops up, boop. All right, cool. That was fun. So that's a basic test. I'm gonna sort of walk through a few other areas. I'm gonna launch the sandbox project here in the background, maybe while we're chatting, just so I can also test the repro just to make sure that also passes. But yeah, so that's kind of the basic idea of the tests. It gets a little more expansive, especially as you kind of look at what you're trying to create. We try to create as many helpers here. Like this is validating when you're updating a value. This is, you know, validating that if you set it to something and then unset it to something else, it'll change. Yeah, we have a lot of helpers. So if you kind of look through these, you'll see the different ways that we're doing something. We have most permutations at this point covered as far as validating colors. The validate has color stuff is really cool because what that's pretty much doing is it generates an image from a platform control, and then it scans it pixel by pixel for whatever colors you're specifying. So it's doing a raw look at the colors to actually see if a color has been set, which is neat. So one of the other things to know about is sort of the way the life cycle of a test works. So everything with a test is set up and destroyed within the scope of a fact. So like XUnit doesn't really have, we don't have any sort of init points or cleanup points or things like that we're hooked into. So it's all just kind of through the fact. So there might be areas where you need to sort of mess with the setup of MAUI, where you might need to register additional handlers or things like that. Like we don't register all the handlers that you might need because, you know, we don't want to sort of have too much behavior happening implicitly. Sometimes that leads to confusing side effects. So if you want to sort of modify the behavior of the handlers or the builder, we have this method you can call, which is ensure handler created. Ensure handler created will pass in the builder. And then this lets you tap into any of the builder elements that you might want to tap into. So you can configure the, let's see. Yeah, see here you can configure the MAUI handlers. So here if you want to register other handlers, you can do that. If you want to add any services, you can do that. And this builder is scoped to the test. This is not a global builder. So anything you do to this builder isn't going to affect any other tests. So the idea here is that it's basically just setting up your builder. So there's a few things this sets up for you, you know, dispatchers, your application, just to sort of try to make your life not too complicated. And we try to do it subtle enough that we don't really get in your way. So yeah, so that's kind of the idea with the ensure handler created. You'll see through some of the classes, we have a setup builder call occasionally. That's sort of just a way, if like the tests sort of have common ways that they're setting up the handlers or something of that nature. You'll see it more sort of in the controls tests where you sort of have to construct more handlers for something. Yeah, all right, but I don't want to get too off track. So yeah, that's the other thing to know about ensure handler created. So for example, let's say you wanted this test to be inside a layout. All right, so what you would do in that sense is you would create a vertical stack layout sub like that. And then you could add the view, you know, you could add the search bar to, if for some reason you need a layout, you could add it to here. like that. And then you would most likely need to sort of add the handler for your, you don't usually have to do this very much at the at this level because each of these tests are sort of localized to your different handlers. So yeah, but yeah, so that's basically how you could do it. Handler dot configure, you know, add handler, and then here you can register your handler. So this also works really well if you need to register a special type of handler. So let's say I'm trying to test some sort of special behavior with the search handler. I would do something like this: custom search handler, bar handler. There it is, like that. And then at that point, I could do add handler, custom search bar handler. Whoops, other way around, like this. Type of search bar stub, like that. Yeah, and so now I've basically wired up a custom handler. So this handler will now get created. This will now get created if I create this search bar stub. So that's useful just if you have just, I don't know, if there's a certain, it's just a nice way to be able to easily sort of swap in a handler for a scope test. So for example, I have a test here with tabbed pages where I wanted to test setting up a custom adapter. So I created a custom tabbed view handler where I wire up my own test adapter, fragment state adapter against the tab page. And so I can kind of test that scenario. So you can sort of swap in and influence the tests in a lot of different ways. The basic setup at the core level, though, is just you have your handler, you have your test type here. All of the tests are it's using generics. This is one difference between here and controls, but in core, all of the core tests inherit a strongly typed handler and then a stub. So that sort of creates the association. So then that's where you can use create. That's why you can use create handler, because it has sort of these generic types. If you look at it, it has these versions that are based on the generics. But create handler also does have a bunch of types if you want to specify your type. So you could do, you know, new vertical stack layout, stub, comma, type of button handler. I don't know if I wanted to create a button handler with the button handler. So now this will assign a handler to your vertical layout stub and go from there. Yeah, so there's a lot of ways to sort of play with things, swap things in and out. Yeah, so you'll run into this pretty quickly. The invoke main thread here is just because the runner runs on a background thread. So to get it to skip over to the UI thread, we need invoke on main thread here, and that's where you have to create the handlers. So if you forget to do that, or you have code that needs it, you'll see it and you'll get a UI kit error or something like that. It'll say, this was marshaled from a thread that doesn't own this or something of that nature. So yeah, so that's the basics of creating a test in core. Now I'm going to sort of create like a contrived set of tests in controls that basically test the same thing, just to kind of show you some of the different features and in the controls level. So in the controls level, like we could pretty much just take this test like here and run it like this, boom, you know, and then this would, I'm probably missing a using, hopefully. Oh yeah, okay, I know what this is doing. All right, yeah. So like we could mostly take this test and pop it mostly take this test and pop it over here. So one of the difference between controls is we don't have the generic base type on the bottom. So there's just a little more that you need to specify with the generic type here. So there you go. So now this test would effectively run pretty much exactly the same as it does on core. But now we're using the XAML control instead of the core control. So because you're using the XAML controller, you could even write this test slightly differently, right? Because in the controls layer, we have a focus call. So you could do focus here. And then here you could do search bar 1 unfocus. So now I'm using the controls level APIs instead of the instead of doing it at core. So that's kind of an important kind of point to note, is that a lot of the times you'll be testing APIs. I mean, you'll kind of see this once you've done your fix, right? Is you're calling a controls level API and you figure out where in core it's broken. And then so you fix it at the core level, if the fix is only in core. So the other API that exists inside the controls layer, which is, it's a much heavier API. So, and you probably won't really use it too often, but we have this, we have an API that's called create and add to window. So the idea with create and add to window is that this is essentially setting up a, this is basically setting up a scaffolding of, this is basically setting up a scaffolding of emulating like an entire, it's basically emulating an entire app that's running. So the idea is that it's if you're wanting to test like an entire page that stood up or replicate running a whole MAUI app, like this is kind of how you would do it, is through the create handler and add window. So this is usually only for much heavier level tests. So like, for example, a lot of the tab page tests do this. The shell tests do this because it has to stand up an entire shell instance to test various permutations of shell and things of that nature. So this is how you sort of stand up an entire app. This is sort of the last point of where you would need to set up a test. This is sort of the last, the heaviest type of test. So ideally you wouldn't need to do this, but sometimes you have to. And then these tests as well work the best if you run them inside. They have to run with any test where we run and you create and add to the window, we run them in sort of a new window collection. So what this does is this makes the collection run single file. So when these are running, they're kind of like they're not going to overlap each other. So it's unfortunate. It's an unfortunate complexity, but you can't have, for example, on Android, 500 tests running in parallel that are messing with the fragments and adding things, or opening new activities, for example. Like there can only really be that one visible activity and things like that. So if you need, for some reason, a test to run isolated, you can use sort of like this collection attribute. And so that's how all of those tests run. Yeah, so that's kind of the basics of, that's the main difference at the controls level, is that there's sort of this added method. Yeah. And that's kind of the basics of tests. As I actually was going over that one, I remembered there is one other one at the core level you can run if you're doing navigation stuff. But, a lot of these are kind of particular to each handler. So, this kind of does similar stuff as in controls, except it tries to do it at the core layer. Like I said, ideally we do as much as we can at the core layer because that's more of a raw validation of how the tests run. Yeah, and so that's the basics of writing a test, really, and how to get the how to get going. So I mean, like I said, it's wherever you sort of have your fix, that's where your tests are usually going to be, right? So here you can see with the search bar, my tests are my changes in the handler, so my test is going to be here in the device tests. And that's where the test is. So to finish this video off, let's run our sandbox app. So in the sandbox here is where I reproduced the issue with the unfocus call. So let's give that a run. Let's see if our test is accurate to what the user reported and if our fix indeed works. Oh. All right, here we go. Now let's see the payoff of all of our efforts. Oh, this is a funny thing. On iOS, you have to actually open the keyboard in the simulator. We get issues about that a lot where people are like, the simulator, the keyboard's broken. And it's like, no, you got to click the keyboard button on the simulator. It's just a funk of how it works. So, all right, if I type things and I click search, look at that. Issue fixed. Users happy. Keyboard closed. Which I've found is like the single most important thing that people want, is to be able to close the keyboard and screw people up. All right, so that's it. Let's watch it again just for fun. What? All right, and we have a test and we have fixed code. So this will never break ever for the rest of time.